Lesson 8, using unit analysis to convert measures. Unit ratios are used to convert measures into different units. For example, we have here 12 inches over 1 foot, 1 meter over 100 centimeters, and 3 feet over 1 yard. What are these three ratios equal to? Well, whenever we have 12 inches over 1 foot, those are the same thing. So because they're the same thing, we can say that each of these units are always, or each of these ratios are always equal to 1. And since we're using them to multiply, whenever we multiply by 1, it doesn't change our value, which is really nice. So we're not changing the value, but we're able to change units, which is going to help us do some of these problems. Some other common ratios it's asking about, something that we use often to convert between the US and metric system would be 2.54 centimeters over 1 inch. Okay. We could also say that 5,280 feet, and under that one we would have to say 1 mile. Okay, those are just some other ones that we know and use frequently. So our first example, it says an elephant can charge at speeds of up to 25 miles per hour. How fast can an elephant charge in feet per hour? So the first thing that we're going to look at is the rate that they give us. And they say 25 miles per hour. So I'm going to show that as a rate. 25 miles per hour, which means 1 hour. But we don't want our answer in miles per hour. We want it in feet per hour. So hour is staying the same. What we want to change is this feet. So we don't want miles, we want feet. So we're going to multiply in order to do that. And we're going to multiply by a unit multiplier. We want miles to cancel out. For miles to cancel, it has to be in the opposite location of what it is right here. So here it's in the numerator, so we're going to move it to the denominator. So we have miles on the bottom, and on top we're going to put feet. So our equivalency between miles and feet is that 1 mile is equal to 5,280 feet. Okay? So now all we have to do is multiply. Miles and miles cancel out. And whenever we multiply fractions, we multiply straight across. So we're going to take 25 times 5,280. And that gets us 132,000 feet per 1 hour. Because that hour just comes straight across. Feet is our label because these two labels are gone. We don't have to worry about those. And we just multiply 25 times that 5,280. Alright, it says the directions on a gallon of paint says the contents will cover 400 square feet. Okay, a gallon of paint will cover 400 square feet. Mary Alice wants to paint the solid wall of her hallways with 2 coats of paint. The wall is 36 feet long and 10.5 feet tall. Will 2 gallons of paint be enough to cover the wall? So she's wanting to cover it twice, 2 coats. So we know that 1 gallon would be 400 square feet. So what we need to figure out is if 1 gallon will give 1 coat, then obviously 2 gallons will give 2 coats. What we need to do first is we have to figure out if 1 gallon is going to cover this wall. So this wall, or at least the walls in my house, are rectangles. Pretend that that actually looks like a rectangle. And what we know about Mary Alice's wall is that it was 36 feet long and 10.5 feet tall. So what's the area of this wall? Well, we should remember that to find the area of a rectangle, whoops, that's an equal sign. Area of a rectangle equals base times height, or length times width, whichever you choose to say, I'm good with. And so we just have to plug them in. So I have the length of 36 times a width of 10.5 so 36 times 10.5 gives me 378 square feet. So, will 1 gallon cover that? Yes, which means that 2 gallons will make 2 coats. 2 coats would be the 378 times 2, which is 756, and 2 gallons would cover 800 square feet. A spray painting apparatus is designed to spray 1,000 cubic centimeters of paint per minute. How long will it take to empty a container that is 2/10 of a cubic meter? Well, first of all, I'm dealing with cubic centimeters and I'm dealing with cubic meters. I can't do that. I have to have the same units. So I'm going to have to change one of these. It doesn't really matter which. I'm going to change the 1,000 cubic centimeters. So I have 1,000 cubic centimeters. Notice cubic meters has an m for meter raised to the 3rd power. Well, that would be the same thing for centimeters. I could show that as cubic centimeters, which is the same as saying centimeters times centimeters times centimeters. Please bear with me on my writing. It's going to take me a little bit to get used to this thing. Okay, so I need to change it to meters. So to change it to meters, I have to have centimeters cancel, and for it to cancel, if it's in the numerator here, it must be in the denominator over here. So I'm going to multiply by, centimeters is going in the bottom, and I want to change it to meters. Centimeters is in the bottom, so it will cancel. There are 100 centimeters in 1 meter. So this centimeter, we'll say, would cancel with this centimeter, but I still have 2 left. So what I'm going to have to do is I'm going to have to multiply by the exact same unit multiplier 2 more times. So I have 1 meter over 100 centimeters, and another 1 meter times 100 centimeters. So centimeters and centimeters, centimeters and centimeters, those cancel. And when I multiply meters times meters times meters, that will then get me cubic meters. So when I multiply straight across, I have 1,000 cubic meters over a 1 with 6 zeros, which is a million, by the way. So 1,000 divided by a million gives me 0.001 cubic meters. So it's going to spray this many cubic meters. Okay? So what I'm going to do now is all I have to do is take that amount that's in the container, which is 0.2 cubic meters, and I'm going to divide it by that 1,000th of a cubic meter per minute. When I do this, this is understood over 1. Okay, so when I do that, the bottom will come to the top, and then B will come to C here. Okay, if you didn't have me for math last year, you may not have seen this. This is A over B over C over D. This will always work for you. Instead of having to actually do the division, you can just move it and do the multiplication. So I have 1 minute times this, so I have 0.2, let me start again here, 0.2 cubic meters minutes over, and then on the bottom this is 1 times the 1,000th of a cubic meter, which means cubic meters and cubic meters will cancel. So 2/10 divided by 1,000 will get me 200, and I'm left with minutes, which we know there are 60 minutes in an hour, so that would get me a little over 3 hours. 3 1/3 hours, or 3 hours 20 minutes. I'm running out of room here. Finally, it says unit analysis is used to convert units of length, mass, density, temperature, capacity, or even money, which is the value of currency can change relative to the value of other currencies. And in example 4, it's giving you the exchange rate for pounds and dollars. Okay, so US dollars to British pounds. And I want you to work on that problem on your own and have your answer ready when you come to class tomorrow.